The only new thing for today is that we're not just adding like terms with exponents, but subtracting like terms with exponents. And what we worked on the last time I saw you was adding like by adding like terms with exponents. You can only do that if they have the same variable and the same exponent. So what you learned last time is that you can only add terms if they have the same variable and they also have to have the same exponent. That's the only thing that's new. The little number on top has to be the same. We also learned some prefixes. We learned that mono, bi, and tri are prefixes that in almost every case mean 1, 2, and 3. Alright, so we are going now to solve an example just with the new thing for today, which is yesterday we added like terms, today we're subtracting like terms. And you can see that right here. The only new thing for today, we've been dealing with, you might want to just immediately say, okay, I know I've got all of these terms here, and I'm going to put a box here, and I'm going to put a box here, and I'm going to combine those terms, but you can't, and the reason why is the new thing for today, which is this negative in between. What that means is that I'm subtracting both of these terms. So I'm subtracting this and this from the original thing. You could think of it like a picture. So if you had a barn and you were subtracting a horse and an owl, that would mean that you're subtracting both the horse and the owl from the barn. So we're going to be subtracting both terms here from this term. And the reason why that's complicated is because these terms can be negative. So I'm going to distribute, okay, so example 1 is I need to distribute the negative that's in between, that is the new thing for today, distribute that negative first. And this applies to assignment number 4. And then the other page that we'll do is assignment number 5. So I'm going to distribute that negative before I do anything. So I draw an arrow from the negative that's in between, in front of the parentheses, a negative to this negative here in the first term. So this is a negative, and that arrow means multiply. So this negative times this negative, a negative times a negative is a positive. So this is a negative times a negative has made this 4k squared into positive 4k squared. And then this negative times this positive, negative on the outside times the positive on the inside. A negative times a positive is going to be a negative. Somebody asked me in class today whether that was the same as keep, flip, change. Yes, it is. In the problems just adding and subtracting that you've done, you distribute the negative because you kept this the same, kept everything here, this had nothing to do with it, and then flipped these two, a negative times a negative, made a positive. So that's why these both turned positive. So you're still doing keep, flip, change, it's just that you're doing it with these terms now. So you could, if you wanted to, keep all these terms the same, flip that, and then that means both of those also have to switch. So this turns into negative, and this turns into positive, and that turns into negative. Let's summarize that really quick. When you have a negative on the outside, what does that do? The minus 4k squared turned into positive 4k squared, and positive turned into negative. How would you describe that? Negatives turned into positives, and positives turned into negatives. When you have a negative on the outside, it switches the sign of the terms that are in the parentheses. So that's the only thing that I've taught you today, which is that if there's a negative outside here, or if you're subtracting a polynomial, that means you switch the sign first. Distribute the negative first. The first step was to switch these signs. And once I've done that, I can just bring things down. So this is 2k to the third minus 7k squared plus 3k. And I combine my like terms, starting with the highest degree. That's this one here. There is no other k to the third, so I've got an exponent of 3, degree of 3, degree of 2, degree of 1, degree of 2, degree of 1. The only 3 was right here, so I can just bring it down. Next, I'm going to do the squared terms. I'm going to use a square for a square. There's a minus 7k squared here and a plus 4k squared there. So I've got 1, 2, 3, 4, 5, 6, 7 negatives coming from this end, and 1, 2, 3, 4 positives coming from that end. So that's negative 7 and positive 4. When I combine those, there's 3 more negatives in the k squared. So negative 7 plus 4 is negative 3. And then I've got one more term. The positive 3k here combines with the negative 5k here. 3 minus 5 is negative 2. And then that's it. Alright, so that was example 1. And what I have taught you is that when you're subtracting a polynomial, distribute the negative first. So your summary should have everything that you learned on this page. Please summarize using at least 2 sentences before you continue. And then the next page we have example 2. This example applies to assignment number 5, and it has weird wording. So the problem is exactly the same, but assignment number 5 is basically a variety of strange ways of wording this. And I should tell you, you will never see a straightforward wording. Like, you will never see something that's just a straightforward problem like this on a test. You will only see one of these weird wordings. So make sure that you do the challenge on number 5. It says subtract this from that. This is a trinomial and that's a trinomial, so I'm subtracting those 2 things. But before I continue, I want to talk about what those words mean. So suppose I were to subtract 3 from 10. Now we all know that 3 subtracted from 10 is 7, but what does that mean about how subtract 3 from 10 looks if you write it as a mathematical expression? Well, to make 7, it's not going to be 3 minus 10, it's going to be 10 minus 3. And if you look at that, you'll notice that here the 3 comes first, and here the 3 comes last. So in this kind of wording, you have to change the order so that the first term comes last when you translate it into an expression. That's also true of less than. 3 less than 10 is also, you have to switch the order. So let's summarize that out to the side here. When in this particular wording, the order becomes backwards from what the expression is going to be. So I'm going to move that over to here for doing the rest of the problem. You can put it either way. You can either put it out to the right or out to the left. So in this particular wording, the order is backwards when you make an expression. So let's see what that means. If I call this entire thing A, term A, and this entire thing is term B, then if I subtract A from B, then that means that it's not going to be B minus A, it's going to be A minus B, it's going to be B minus A. If you subtract A from B, then that means it switches the order to B minus A. And now I could have B be this entire trinomial, so that's this whole thing, and then A could be that other whole trinomial, that's that whole thing. So you would need 8x squared minus 6x plus 2 would all go here, and 3x squared plus 7x minus 4 would all go here. Alright, so what I have just taught you in example 2, this problem is not finished. You still need to distribute the negative, which, if you remember from the previous page, when you have a negative on the outside, it's going to switch the sign of all the terms in the parentheses. I have a negative on the outside, and so I'm going to switch the sign of all the terms in the parentheses here. And then I'm going to combine my like terms. But all I wanted to teach you on this page was that in the wording, subtract A from B, B comes first. So this expression comes before that expression. So subtract this whole thing from that whole thing. I'll just do the switch the sign step for you. This was positive, it becomes negative. This was positive, it becomes negative. This was negative, it becomes positive. And then you can combine the like terms on your own. Okay, so combine, if you would please, finish this example by combining, for example, 8x squared and minus 3x squared.